Hello everyone. In this video, I am going to discuss why the transformer cannot work on DC supply and why the rating of the transformer is measured in volt amperes. Suppose if the DC supply is given to the primary winding of a transformer, because of this DC supply, there is a flux set up in the transformer core, and the flux is not alternating because of the DC supply. Only we are getting DC flux, constant flux in the transformer core. As we know, as there is no change in flux, there is no EMF induced in the coil. According to the Faraday's laws of electromagnetic induction, when there is a change in flux with respect to the coil or conductor, then only EMF is inducing in the conductor. And here we are giving DC supply. Because of this DC supply, we are getting DC flux, means constant flux. Because of this constant flux, flux is constant and conductor is also constant. Therefore, there is no EMF induced in the conductor. Okay, suppose if forcefully we are giving DC supply to the primary winding of a transformer, DC supply to the primary winding of a transformer, the entire current will flows in the transformer core. Primary winding and the primary winding is attached to the core. The entire current, supply current is flows in the transformer core. After sometimes the core will get saturated. The core will get saturated. Because of this, it will draw excessively large amount of current. It will draw excessively large amount of current, which may damage the winding of the transformer, or which may burn the primary winding. This is clear. That's why transformer never operated on DC supply. Is this clear? Yeah. Next topic. And why the rating of the transformer is measured in volt ampere. Okay. Generally, the rating of the transformer is in volt ampere or kilovolt ampere or megavolt ampere. KVM is kilovolt ampere, MVM is megavolt ampere. The rating of the machine indicates the power supplied by it. Remember, whenever there is a rating, suppose it is volt ampere or kilovolt ampere or megavolt ampere in the transformer, it indicates the power supplied by the device. It indicates power supplied by the device. Uh, Generally, the rating of the transformer is depends on the losses occurring in a transformer. Is it clear? Generally, the rating of the transformer is depends on generally the rating of the transformer is depends on losses occurring in a transformer. Depends on the losses. Okay, generally there are two types of losses in a transformer. One is core or iron loss, and next one is copper or I square or loss. Core loss or iron loss, copper loss or I square or loss. Okay, now in these two losses, one losses depends on the supply voltage and another losses depends on the current. Another losses depends on the current. Is it clear? The core or iron loss depends on supply voltage. Core or iron loss is depends on supply voltage. Remember, it is very important. Core or iron loss is depends on the supply voltage. Core or iron loss is depends on the supply voltage. And the copper or I square or loss. The copper or I square or loss is depends on the supply current flowing through the windings. This depends on the current flowing through the windings. Because of these two losses present in a transformer, one losses depends on supply voltage, another losses depends on current. We know that the units for voltage is nothing but volts, units for current is nothing but amperes. Therefore, the rating of the transformer is expressed in volt ampere or kilovolt ampere. Okay. Why it is kilovolt ampere means generally we are generating electricity from the generating stations in terms of kilovolts. In terms of kilovolts. The purpose of transformer is to transfer electrical energy from the generating stations to the distribution station. Generating stations to the distribution station. The available power in the generating station in terms of kilowatts. That's why the transformer rating also measured in kilovolt ampere. Is this clear? Yeah. This is the way rating of the transformer is measured in volt ampere or kilovolt ampere. Thank you.